Hello friends, सबको नमस्ते. So today in this video we will create a pothole detection using a YOLO model. Suppose if your data set in a zip file is uploaded in your Google Drive, you can copy the share link and just paste this part in this cell. Okay, this much, and just run this cell. Your zip file will get uploaded here. First it will connect with CPU or GPU. Wait for that. It's connected. Now see it's running. This is a zip file. Now to unzip it, just use this. See, this is a dataset, Polar dataset. It's contained two folders, test and train, images and labels. Okay, you can see that there is not a YML file in this, and so we have to create our own YML file because YOLO basically require the YML file to know that where the folder is, where the trained images, where the test images. To get this knowledge, we have to create our own YML file. So this is how we can create a YML file. This is a data path, train, validation, test, and NC. Number of classes which we have is one. Name is Pothole. And you can see this in validation I kept a trained images because using a train images we can use validate. You can compute the validation. Okay. With open pothole.yml file, W is write mode, S file, yml.dump which data we have to dump data, and in which file. And this way you will create your own YML file. Okay. Let me refresh it. See, it's come. You can see this is data which is required by the YOLO. Ultralytics basically is a library where from which we can upload the YOLO models. See, now we use from Ultralytics import YOLO and load the predator model. We are using YOLO11 L.pt. You can see this. There are multiple YOLO11 multiple models and S, M, L, and X. The model which we are using is YOLO L, which is trained on 640 to 60 pixel size with parameters 25.3 million parameters there. So we are using this one. After loading it, we have to train that YOLO model on our own custom data set. So for that, we have to use model.train. Just pass the YML file, which keep details how where the data set is there and other things. I don't want to train with 50 epoch. I will train only with 5 epoch just for the explanation purposes. And I already have you can see the weight file which is trained on 50 epoch. I will upload it later and show you the result of that model. Size is 640, batch is 8, means when the images is divided into batches, I want 8 in one batch. I want 8 images, and this pothole YOLO V8. When you will run the cell, run folder will be created. Inside the run folder, detect folder will be created, and inside the detect folder, one folder will be created whose name is decided by us, whose name will be this, and inside this folder, wait folder will be there, and inside the wait folder, model will be saved. Okay, save true. Yes, we have to save the model. Save period -1 means we do not want to save every epoch weight. We only want to save the best model. So save -1. Patient 20 means early stopping, means we want to stop the epochs, or you can say training, when there is no improvement in loss or in accuracy. Validation false, since we do not have a validation folder, we can cap it false. Otherwise you can cap it true, but the images used by the validation is during validation, the images used by the YOLO will be train images. And you already know that in validation purposes, weights does not get updated. Okay, only in training, during training time, during when the train images will be used, at that time only weights get updated. During validation, weights value does not get updated. Okay, now let me run this cell. This way our training gets started for 5 epoch. And now you can see that here, see here, the folder will get created when the training gets started. You can see this run folder get created. Wait for the seconds. See, our training guide started. See, so before that, let me complete this training. But before that, let me explain this. This is a function in which I will draw the bounding box around the object, and here the object is a pothole around the pothole with different color. So first pass the image, then the box. Box is a variable which capture information of the bounding box, and here label basically describe the pothole, a string you can say, and the color sample is a list of the colors. So list of the colors, I have to select a random choice will be there for selecting one color from this list. Then we have to copy the image. First we have to create the copy image, then map int box. Now we have to retrieve, or you can say retrieve all the information inside the box with the xmin bymin, xmax and bymax. And what is use of int? You can it might be possible that the values of xmin bymin and xmax and bymax inside the box variable is in a float, but I want all those values in the int. So I have to use here int, which map, it will map all the values with this xmin bymin, xmax and bymax, this all four values. Then I have to create a rectangle. Just for the creating a rectangle, use cb rectangle with pass the image, xmin by min, top left corners, bottom right corners, and then the color, and the 5 is the thickness. Now I have to display the label, and I want to display the label below below the bottom left corner of the bounding box. Okay, for that the coordinates will be xmin and ymax. Okay, these are the coordinates for the bottom left corner of the bounding box, and I have to add some padding. For that I have add 40 pixel padding. Here one is a string, so not a string, it is a size of the string, then the color, 3 is the thickness, this is a line, and just return the image. So it will run when this training get completed. Now see this, run, inside run detect folder. Inside that detect folder, the folder name which we have given, inside that folder, wait folder will be there. And you can see that inside the wait folder, two wait file will be there, best and last, and we have to use best, so we are using here best. Then the text directories, there is no dataset folders. This is a, I already told you, this is a list of all the colors which we want. And after that I have to make the list of all the images present in the text directory, list of all the file name. So I have used a list directory, and I have to display 16 images. 16 images means 4 rows and 4 columns. So here 4 rows, 4 columns, and each figure size will be 16 by 16. We are using plot.subplot. Okay, here figure is basically representing the entire image. X is X is used for the iteration over the subplots. Here you can see uh, X is used for the subplots, but here X is basically is a 2D format in the here, but after using a label, it is in a 1D format because I converted it because I want the iteration over the subplots will be easy. I don't want to iterate in a 2D format. Now I just want to display 16 images, so I have to iterate 16 times. I have to first select a random choice from a random choice image file name, means image random choice of the image. Then I have to create the image directory, means the image path. So for that, I have used os path.join. It has image directory and the image name. This way, then I have to read the image. Now here you can see that I have passed the image path, not the image. So no problem is there. Either you can pass the image path or the image after reading with CB2. CB2, there is no problem and there is no error will be shown. Okay, it's up to you what you want to use. And this 0 is basically representing that we are passing just single image to get the prediction or result of that image. We want to use 0 for retrieve the information for the first image. Now result dot boxes, why I had used for loop, because it might be possible that in single image multiple boxes will be there, or in single image multiple pothole will be there. So that's why I have to, for representing and each pothole, I have to iterate over it. So result dot boxes, and after that all the information just works for when I will talking about the first iteration. All information will be stored in box. Then I have to retrieve information. So for retrieving information, x by 0, Here 0 is representing the for the single image that we are passing. Then the class, which class it's belong. After getting the class, I have to know the class label, means label, pothole and other things. So to get the label, we have to use model names. Then we have just passed the all things in the drawing boxes function, which we have which I had explained you above in our code. Then you can see that the image is written CB2 format, and you already know that not CB2 format by read by the CB2, and CB2 read the image in the BGR format. Then I have to convert it into RGB here. You can see this. Then show the image, and this is all the pilotation. Okay. Now I think so. Training got completed. Yes. So let me show the result of the model which is trained with 5 epochs. See the result. It's quite working good, but multiple bounding boxes on single pothole. You can see this. So now let me upload the model which is trained with 50 epochs. Okay. So this is wait file, open it. Okay. Now this is the epochs. You can see this. Now you can see this 985 is presenting the total images which is used for training, and here 124 is the batches. Now for beta calculation, I will explain you. When we have 985 images and I have used 8 as a batches, so let me divide with 8. You can see this 123 batches is created, but when you multiply 123 with 8, you can get 984, and we have 985 images, so one images is get rejected. So to overcome that problem, so to include that image, we have to increase the patch. So 124 patch is there, and this is a losses, box loss, classification on DFL loss, and GPU memory is that is the memory used by the GPU. 5.81 GB is used by the GPU, memory used by the GPU. So I will come back when the uploadation of my model get completed. Okay. Since my uploadation is completed, you can see this pothole.pt, my model which is trained on 50 epoch is completed. Let me show the result of that. Okay. Let me run this cell. So you can see the result. It has better accuracy than the model which is trained on 5 epoch. Okay. Somewhere is lagging. Okay, but you can increase the accuracy of the prediction using increase the epochs, or you can also increase the images using the data augmentation. Okay, so that's it. I have already explained you each and every line. Hope you understand well. So please like, share, and subscribe. Thanks to all.